All right. Well, thank you, Donnie, for lining this up. And thank you, Mark, for participating. And thank you, everybody, for tuning in tonight. And hopefully, when it's all done, you can see information on both sides of the topic and other sources where you can go get more information. Because, like I said before, I want people to get all the information to make informed decisions. And that's not happening in our schools, in our media, in our museums. So I'm giving everybody an opportunity to think, because if you only see one side of the issue, you just memorize. And you can go ahead and share that for me, if you would, Donnie. And we need to make some definitions. And according to the National Academy of Sciences, the National Academy of Sciences defines science as the use of evidence to construct testable explanations and predictions of natural phenomena, as well as the knowledge generated through this process. So notice the key word, it's testable. If it's not testable, according to the National Academy of Sciences, it's not science. And I'm paying for this textbook with my property tax, so I'm going to use this definition. I'm also paying for this, evolution. All life on Earth is related to a common ancestor that existed about 3.8 billion years ago. This process is called evolution. So when I say evolution, I'm not talking about big beaks or little beaks or changes in the genome. I'm talking about all of the plants and animals and people that have ever lived coming from a single living cell, a common ancestor. And we need to separate the facts from the conclusion. This is from a science college textbooks that I bought. It says a fact is a verifiable piece of information, whereas a conclusion is a judgment based upon the facts. Okay, so a fact is verifiable. Okay, tonight we got the same facts. What we're discussing is the conclusion, the interpretation of the facts. So we have to be very careful about separating those. And then this next statement, it's the ultimate pot calling the kettle black. The news media, often mix facts with conclusions without indicating which is which. Well, so does the science book, and so does the science journals, giant science journals, and so does this national park website. Notice at the bottom it says the park is dominated by the spectacular Grand Canyon, a twisting 1 mile deep and 277-mile long gorge. Okay, that's verifiable, so that's a fact. And then they throw the conclusion in with it. This is an interpretation based upon the fact, but it's not a fact. It says formed during some 6 million years of geologic activity and erosion by the Colorado River. Okay, so that's not verifiable. That's not testable. Okay, so that's a conclusion, and they mixed it with the facts. That's what we're going to have to get good at tonight. And even Nova does it. Paleobiologist Mary Schweitzer has defied the long-held belief that it is fruitless to search for preserved soft tissue in dinosaur remains. Most experts thought that such structures would have decayed and vanished long ago, and rightfully so, because that's what all their scientific experiments show. But Schweitzer has found evidence of delicate structures such as blood vessels and red blood cells. Now, that's a fact. That's verifiable. We can see that. And then they throw their conclusion in. The blood cells that have survived for millions of years. Okay, that's not a fact. That's a judgment. They could have just as well thrown mind judgment in there. The blood vessels and red blood cells, that indicates that dinosaurs did not live millions of years ago. So what you're going to see tonight is we have the same facts. It's just, how do we interpret them? That's what the difference is. And we're going to be looking at evidence. Let's take a look at high confidence evidence. This is repeatable and testable, and it's directly observable. It's prospective, and it's careful to avoid bias. And you do that by doing blind tests, or even better yet, double blind tests. And it's careful to avoid assumptions. The fewer assumptions you make, the stronger your theory is. And the more accurate predictions you make, the more robust your theory is. And then it makes reasonable claims. Now, low confidence evidence is not testable. It's not repeatable. Nobody saw it, and it's looking backwards. And there's clear opportunities for bias. And one of the biggest biases is to eliminate any opposing ideas. That would be a methodological naturalism, where they say all there is matter and energy. That's all you're allowed to think in. You got to stay in this material box. And so they eliminate everything else. And if that's the only horse in the race, of course they're going to get all the grant funding. Okay, and then there's many assumptions that are required, and then overstated claims. Okay, so what's an example of high confidence evidence? That would be, how fast does an object fall? You can test it. You can repeat it. You can observe it. You can do it over and over and over again. And if you make a reasonable claim, it's like, this is how fast it falls. That's high confidence. What's low confidence? Do humans and bacteria share genes from a common ancestor? Well, that's not testable. That's not repeatable. That you haven't seen. And there's no respect. You're looking backwards, and there's bias there. One of the biases is there's no God. So now it just has to be from a common ancestor. And there's many assumptions and also many rescuing devices. And the more rescuing devices there are, that's something that's imagined to be true. That can't happen. Okay. And so now we're going to make claims tonight, like this one is in a textbook. Organisms as dissimilar as humans and bacteria share genes inherited from a very distant common ancestor. So is this high confidence, testable, observable? No, this is low confidence. And so that's what I'm going to try and tonight. I'm going to try and stay on the high confidence side of the evidence. And if you want to learn more about this, Dr. Rob Stadler, he wrote the book, The Scientific Approach to Evolution. And I'm going to give people sources tonight so you can learn on your own. You can go onto YouTube's TCCSA and you can listen to him talk about it and other things. It's broken up into biology, astronomy, geology, and you can see what creationists say on those things. And then now let's talk about the elephant in the room. Miracles. These are things that violate laws of physics, and everybody believes in it because everybody needs to get matter from nothing, violates the first law of thermodynamics. Order from chaos violates the second law. Life from non-life violates the law of biogenesis. Immaterial ideas from matter, that's Einstein's gulf that he said was unbridgeable. And consciousness from matter, which I don't think I've seen anybody try to explain. So let's just look in the third one. How did life begin? Was it by blind chance or was it by creation? And this is what the college textbook says, to the best of our knowledge. It should say to the best of our knowledge based on a blind chance perspective of the past. And it goes down and says somehow, despite this harsh environment, living organisms appeared. So they don't have a clue how it started. Somehow is not science. It should not be in a science book. That's definitely not testable. And if you go up there, it says that it rained on hot rock for millions of years. And that's what happened before somehow. So technically, if you believe in blind chance, you believe that we came from rock. Okay, and they haven't started. You can get $10 million. All you have to do is solve the largest mystery in history, how genetic code inside cells got there and how cells intentionally self-organize, communicate, then purposefully adapt. And so let's take a look at what's happening inside our cell.
Now we see the polymerase in action from the outside as it spits out the messenger RNA transcript. Next, this RNA transcript approaches and passes through a molecular machine called the nuclear pore complex, an information recognition device that controls the flow of information in and out of the cell's nucleus.
So did that get there by blind chance, or do you think that was created? And we can do
we see the genetic assembly instructions on the messenger RNA approaching and arriving at a two-part chemical factory called a ribosome, the site of protein synthesis.
And we could do all night on that, just what's happening in a cell. But you can see this on YouTube, Discovery Science, and its journey inside the cell. And then where did that information recognition device come from? And you guys can vote in the chat. Was it A, blind chance, or B, creation? This can be interactive. And how about kinesin?
Cells are full of specialized components that perform functions vital to their existence. But how do these components get to the right locations inside the cell to perform their functions? For larger components, a transportation system is needed. Meet the kinesin. Masterpieces of microengineering, kinesins are miniature motorized machines that carry cargo from one part of the cell to another, walking along self-assembling highways called microtubules.
It's like, what? They get there by self-assembling highways? Well, how do those highways know where to bring that stuff? Is that by chance? And so you can vote. It's like, and my son saw that. It's like, well, where do they get the energy to move? That's ATP synthase.
ATP synthase is a high-tech micromolecular power generator inside the cells of your body. It generates adenosine triphosphate, or ATP, an energy molecule that provides fuel that every one of your cells needs to function. Without this fuel, your cells will cease operation, and so will you.
So without the fuel, your cells cease operation, and so will you. So you're going to die without this. My question is, how did we live before this evolved? And notice the multiple parts working together with precision timing.
ATP synthase machine has many parts we recognize from human-designed technology. A rotor, a stator, a drive shaft, and other basic components of a rotary engine. The ATP synthase is one of thousands of elegantly designed molecular machines inside your cells that make your life and all known life possible.
So this is just one of thousands of your cells, and that's happening trillions of times over in your body right now. Is that happening by chance, or was it created? And they slow it way down. It's not like that. It looks real slow, but it's not. Check this out. And this is on Discovery Science. You can check that out.
It doesn't look all that complicated until you realize it looks more like this. In this, it's slowed down by more than tenfold. And the cell membrane is so densely packed with these machines, they effectively make the entire surface of the membrane.
Yeah. And so did that happen by chance? And the average human uses a billion trillion ATP molecules every second. And that's your entire body weight of ATP every day. So you stay alive. And again, how did you live before that? And so where did that ATP come from? Go ahead and vote. Do you think that's blind chance? We're just lucky as can be that all those things are going to the right place at the right time to keep you alive? Or do you think there was a creator, a creation involved? And so real quickly, we're talking about the proper perspective of the past. Is it by blind chance or is it creation? See, I went even farther. You know, it's the Big Bang. People think that the universe got here by chance, and other people think humans got here by chance. That's the Big Bang and evolution. I just loop them together and call them blind chancers. We talked about science. It needs to be testable. Evolution, we're talking about common ancestors. And we really need to separate the facts from the conclusions. Facts are verifiable. And Mark and I, we got the same facts, but we have different conclusions. And then we have to look at what evidence is being supplied. Is it high confidence? Is it testable? Or is it low confidence? Is it just imagined? And then we're going to look at the miracles and then the complexity of the cell, and then also the sources. And then I'm also encouraging, I think that we should have multiple theories that people should look at so people can think. And that's the other thing. So I encourage you to get a pen and paper and just write down the sources so that you can go out and check it out and make a really good informed decision. And that includes, you got to see both sides if you want to think. And that's not happening in class. So thank you so much for Donnie for putting this together. And thanks again, Mark, for getting up in the morning and talking to us from Australia. It's a pleasure to talk with you.